Hello everyone, in this video we will learn the concept of what are the steps involved in the RSA algorithm and its examples. In RSA algorithm, we are taking the two large prime numbers. So these two large prime numbers, we can say that the value of our P and Q. In the first step, we are taking the values of our P and Q. In the second step, we are taking the product of that two large prime numbers, that is P into Q. In the third step, we are identifying the value of phi of n is equal to P minus 1 into Q minus 1. In the fourth step, we are finding the value of our public key, that is nothing but value of E. Whenever we are finding the value of E, then we are taking this formula like 1 less than E less than phi of n. And our value of E should not be the factor of phi of n that we have identified in the step number 3. So our E should not be the factor of phi of n. In the fifth step, we are finding the value of our private key. So in the fifth step, we are finding the value of our private key. So our value of private key D is equal to value of D into E, that is mod of phi of n is equal to 1. Now these are the 5 steps that we are identifying it for value of our D and E. Now whenever we are finding the encryption, that time we are finding our ciphertext message. So our ciphertext is equal to P raised to E mod of n. And for decryption, we are using that formula like P is equal to C raised to D mod of n. Now let's begin with the examples. In the given example, P is equal to 7, Q is equal to 17. These are our two prime numbers. Value of private key is given, that is D is equal to 23 and our ciphertext value is 12. And now we have to find out the value of our public key as well as our plaintext. So our first step is we are writing P is equal to 7 and Q is equal to 17. Now we are finding N is equal to P into Q. So P into Q is nothing but 7 into 17. That is 119. And now phi of N is equal to P minus 1 into Q minus 1. And we get the value like 7 minus 1 into 17 minus 1. That is 6 into 16. So 6 into 16, it is nothing but 96. In the fourth step, we have to find out the value of our E. So now we are finding the value of our E, that is our value of our public key. So our value of our public key should be 1 less than E less than our phi of n. So in the given example, E is not given, the value of D is given. That's why we are writing the formula like value of D is 23. So we are writing the formula like D into E mod of phi of n is equal to 1. According to this formula, we are finding the value of our private key. Now we are putting the value, that is 23 into E mod of phi of n. So phi of n is 96 is equal to 1. So after getting the value of our E, this formula should be equal to 1. So now we are finding the value of our E based on the extended euclidean algorithm. By using this method, we are finding the value of our E. As per the extended euclidean algorithm, we have to make the column like quotient, value of our A, then B, then remainder T1, T2 and T. Our value of phi of n is equal to 96. So we have to write the value of A is equal to 96. Then our value of B is nothing but our value of our D. So we are writing the value of our B is equal to 23. So A is equal to 96 and B is equal to 23. After that, we have to find the 96 divided by 23, and we got the value 4 as a quotient and 4 as a remainder. Now we have to shift the value of 23 into A and 4 into B. Again, we have to follow the steps again. So 23 divided by 4, quotient is equal to 5 and remainder is equal to 3. Same we have to follow the steps for 4 and 3. So quotient is 1 and remainder is 1. 3 is shifted now in A and 1 is shifted in B. So 3 divided by 1 is equal to quotient of 3 and remainder is equal to 0. Again we are shifting 1 in column A and 0 in column B. Now 1 divided by 0, we will not get the value of our quotient as well as remainder. So we are doing cross mark in quotient and remainder column. So now this process is completed. Now we will move into the T1, T2 and column T. So as per the algorithm, we are putting 0 as a T1 and 1 as a T2. And value of our T is equal to, according to the formula, T1 minus T2 into quotient. So we have to put all the values of our T1, T2 and quotient from the first row into our formula. Then we will get the value of T is equal to minus 4. So we are writing here minus 4 in column T. Now again we are shifting 1 in column T1 and minus 4 in column T2. Again we have to put all the values into our above formula, that is T is equal to T1 minus T2 into quotient. After putting the values into column, we will get the value 1 minus 4 into 5, that is nothing but 1 plus 20 is equal to 21. So we are writing 21 in column T. Now again we are shifting minus 4 in T1, 21 in T2 and then we get value of our T is equal to minus 4 minus 21 into our quotient, that is 1. And we will get the value T is equal to minus 4 minus 21 is equal to minus 25. Now again we have to follow this step again. So 21 and 20 minus 25 into T1 and T2 respectively. So T is equal to 21 minus 25 into our quotient 3. So we will get the value of our T is equal to 96. We are writing 96 in column number T. So again we are shifting 25 and 96 there, that is minus 25 and 26, 96. So in our T1 we got the value minus 25 and in our T2 we got the value 96. So we are taking here T1 plus T2, that is minus 25 plus 96. We will get the value is equal to 71. So we are writing here 71, and now we are writing E is equal to our value of public key is equal to 71. Now we are using the formula for encryption as well as decryption, like C is equal to P raised to E mod N, and for decryption we are using P is equal to C raised to D mod N. Here we are finding our ciphertext in the process of encryption, and in the process of decryption we are finding our plaintext. In the given example, we have the value of our ciphertext, that is given 12, and value of our private key is equal to 23. So we are writing here P is equal to ciphertext raised to D mod N. So 12 raised to 23 mod of our N, and value of our N in our example, that is 119. So we are writing here 119. So whenever we are finding the value of 12 raised to 23 mod of 119, then we are doing it in simple step like 12 raised to 1 mod 119. So 12 raised to 1 mod 119, it is nothing but 12. Next, we have to find out 12 raised to 2 mod 119. So 12 raised to 2 is nothing but 12 raised to 1 into 12 raised to 1 mod 119. And we get the value 12 into 12 mod of 119. And we get the value 12 into 12 mod 119 is equal to 25, or either we can write it as minus 94, because 25 minus 119 is nothing but minus 94. So we can also write it as minus 94. Now we have to find out 12 raised to the 4 mod of 119. So 12 raised to 4 mod of 119 is nothing but we can also write 12 raised to 2 into 12 raised to 2 mod of 119. So 12 raised to 2 is nothing but 25 into 25 mod of 119. So 25 into 25 mod of 119, our answer is 30, or either we can write it as minus 89. Now we have to identify the value of 12 raised to 8 mod 119. So it is nothing like 12 raised to power 4 into 12 raised to 4 mod of 119. So 12 raised to 4, our answer is 30 into 30 mod of 119. And now after answer is, after calculation we will get the value 67 or minus 52. For calculating 12 raised to 16 mod 119, we will get the value 12 raised to 8 into 12 raised to 8 mod of 119. And we will get the value 12 raised to 8 is nothing but 67 into 67 mod of 119, and we will get the value 86, or either we can write it as minus 33.
So in the next iteration, we are finding 12 raised to 32. But in our example, in our encryption process and decryption process, first of all, we have to check what is the power. And in our decryption, the power is 23. So now we will not go to the step that is 12 raised to the 2 power 32. We are directly moving to 12 raised to 23 mod of 119. So 12 raised to 23 is nothing but we can also write 12 to the power 16 into 12 to the power 4 into 12 raised to power 2 into 12 raised to power 1 mod of 119. And now we have to put the value. So for 12 raised to 16, our answer is minus 33. For 12 raised to power 4, our answer is 30, or either we can write minus 89. Then for 12 raised to power 2, our answer is 25, or either we can write minus 94. So now we are considering here 25 and 12 raised to 1 is nothing but 12 mod of 119. After calculation, we will get the value like 774000 mod of 119. And for this, we can write our answer as 24. So 24 is the value of our plain text message. So in the given example, value of ciphertext is given, that is 12, and value of our decryption key, that is D, is given, that is our private key, is given 23, and based on that we have find out our value of our plain text message, that is 24.